What is a Reaction Plan Manager++ solution? A solution has two functions. One function is to read the data from the data source and group it. The other function is to perform an analysis and generate a report. There's a mechanism inside RPM called the data collector, which will let you set up how the data is read and grouped. We call groupings filters. So the data collector sets up how the data is read and filtered. The analysis is handled through a mechanism called reaction plans. You'll set up the logic to analyze the data collected from the data collector and generate the appropriate instructions for the operator through the reaction plans. So your goal in designing a solution is to set up the data collector and reaction plans. We're ready to start working on the development process of our solution. Well, first thing I need to do is click on the Edit button to get to the editing tools. The first step in the development process is to set up your data collector. You'll notice at the top there's a button here called Data Collector. If I click on that button, the right-hand side of the screen changes. We now have tools where we can actually set up the data collection. You'll notice you've got three tabs up here. You've got a General tab, a Filter tab, and a Configure Data Collection tab. Below that, you've got a table which actually has the data that came across from your data source. You'll notice you've got green rows and white rows. The green rows represent header records. The white rows represent part data. And if I look at the rows, you've got nominal, plus tolerance, minus tolerance. And at the top, you've got labels for each one of the dimension items. These are dimensions, 1x, 1y, 1tp, etc. And you've got the nominal value, the plus tolerance, minus tolerance, and the actual data down below. So it's delineated by, the columns are delineated by dimensions. Towards the end of this particular data set, you've got machine, stream, and date. These are filterable items. Remember, when you set up the data collector, you need to set up how the data is read and how the data is grouped, or in other words, how it's filtered. So this is important information. Now, as far as how the data is read, that is really set up when you set up the software. If it knows the data source, it'll set up a lot of these defaults for you, so you really don't have to worry about them. The thing you have to set up is the filters. If I click on the Filter tab, you notice I've got Add Filter, I've got column and name. So you have to tell it where the column is that contains what the item you want to filter on. So in our case, we're going to filter on the machine. If I click on any cell in this column, which is labeled machine, it'll put an entry into the column. And for the name, I'll call it machine, because that's the name I want to associate with this filter. I could add additional filters if I want. It's just, I'm going to just filter on machine. Now I'm going to click on the Add button, and it adds the filter. Notice the filter column isn't a reference to the column. It's not AA, it's actually machine enclosed in pound signs with a greater than, a less than sign in front of it. This is a variable. Reaction Plan Manager tries to use variables wherever it can so that you're not locked into a specific column which contains the data. So in other words, if machine ended up in some other column besides AA, it'll still find the data. Now you're probably thinking, okay, well, how does this work? I've got a filter set up. What does that really mean? Well, this is how it works. When the data is read from the file, it'll group it, and then it will look for a reaction plan here on the left-hand side. These are a list of all the reaction plans that exist in the system, well, in this solution. If it finds the reaction plan that meets the filter criteria, it'll pump the data to that particular reaction plan. If that reaction plan doesn't exist, it will build a brand new reaction plan and add it to the list. It'll build it from the template. You can think of the template as like the base reaction plan. All of the plans are written based off of the template. Notice you have a blank plan here. Well, the reason you have a blank plan is because when the Auto Solution Builder built the reaction plans initially, there were no filters set up, so it just dumped all the data into this empty plan. You can click on this Process Data button here. It will go through the data that you currently have in this table, and it'll figure out what reaction plans to build, and it'll add to this list whatever the filter combination is. So I'm going to go ahead and do that and watch what happens. We now have a new plan called Machine A. Machine A contains the data for Machine A. If you want, I can delete the blank plan. If I click on the Delete Reaction Plans here, I'll choose the plan that has no filter and then delete it. You also notice you have an offline plan. The offline plan is used to do experiments. So you'll work on your solution and you want to test it. So you can go to the data collector, go to the general tab, check this add data to offline plan for quick check, and then hit the play button, and it'll process the data. It'll ask me how many parts you want to analyze. I'll say 2. And then it'll pump the data to the offline plan, and you can look through it and see if your logic is if your action plan is providing the appropriate instructions to the operator. Let's switch to the view mode. Notice the offline and template plans are not visible. They're in the solution, they're just not visible when you're in the view mode. Operators don't need to see that. That's really more for you when you're developing a solution. Let's go back to the edit mode and continue developing the solution. The data collector is complete. Now it's time to start working on our reaction plans. A reaction plan is divided into 2 areas. You have the header area at the top and the viewing area below. It's a point, click, and configure process. So you pick the item in the viewing area that you want to edit, or you pick the header at the top if you want to edit the reaction plan's behavior. So for example, if I want to edit the 1x dimension item here, I'll click on that item. You'll see it's highlighted. And I've got a menu on the right hand side that I can make changes to the dimension item. If I want to make changes to the behavior of the reaction plan, I can click on the header. So for example, if I want to set it up so that by default it hides the dimension items that have normal severity, I can uncheck the severity level here for normal and then save those changes. And now by default in the view mode, it'll hide the dimension items that have a normal severity level. The most important object in a reaction plan is the dimension item. The dimension item is where the data flows into. It's where the calculations are performed. It's where the calculations are compared to rules. If there are any rule violations, it'll display the specific instructions to tell the operator what to adjust, how much to adjust by, and in what direction to adjust. All this is in a dimension item. Since the dimension item is so important, I want to spend time talking about the settings for a dimension item. I'm going to click on the More button on the 1Y dimension. You'll see you've got dimension info, process info, and last run info. Dim info is the dimension information. It talks about the type of tolerance type of dimension that you have. It's bilaterally expressed tolerance. The nominal is 0, the plus tolerance is 0.06, minus tolerance is minus 0.06, etc. The process info represents all the parts contained in a dimension item. We've only measured 2 parts, so you only see 2 parts. Hence, the number of parts is set to 2. You notice you've got the average, max, min, range, standard deviations, CP, CPK, deviation from nominal, out of tolerance, and the correction. Last run info is a smaller subgroup. Right now it's set to 1. So our average is, it's average. There's only 1 part, so the average is actually the location of that part. Max, min, range, standard deviation, deviation from nominal, out of tolerance, and the correction. Now if I want to edit this, I'll click on it, it's highlighted, and now we can go over the different settings. And you have a general tab, nominal tolerance tab, advanced message overrides, advanced output. I'll talk about the advanced tabs in a little bit. Last run reaction and process reaction. The general tab is where you can change general information about the dimension item. For example, if you want to change the name, I can change it here. The type of dimension. Your choices are normal and auxiliary. If I set this to auxiliary, the dimension item will be invisible to the operator while in the view mode. It'll still receive data, it'll still do the calculations, the operator won't see it. Message when no rule is violated. If everything is good, this is the message the operator is going to see. GD&T symbol. I'm going to set this to distance. You can choose a whole list of different dimension types of symbols. Startup graphics. It's set to condensed by default. If I like this, I can change it to detail. We'll go ahead and change it to detail. You have detail, condensed, summary, and none. Summary is similar to condensed, where you have a smaller graphic, but you have the corrections on the right. None, you do not have a graphic at all. You just have the instructions to the operator. The process reset. If I have this checked where it says display process reset button when rule is broken, it will reset the part counter when button is pressed. So the idea behind this is if I have this checked, it'll display this button. See this button here, press button if adjustment made. So if the operator presses this button, it'll reset the part counter, and it'll assume he's going to go out and manufacture another part, measure it, and send the data through Reaction Plan Manager again. If the correction was done properly, it should have fixed the problem, and it should go back to nominal. You can check the next setting if you want to reset the part counter for all the dimension items in the document. If this particular dimension item, this particular adjustment I should say, affects all the other dimension items in the process, if you have this checked and the operator hits the button acknowledging he's going to make an adjustment, it'll reset the part counter for all the dimension items. The number of parts to queue before applying a process reset. The next 2 settings are really more for an automated system. If I've got a queue of parts and the operator is going to make an adjustment, he could, actually the operator wouldn't even be involved in it. It would be more of an automated system. This number determines how many parts it will pass before it actually performs a process reset. The next setting is number of parts before monitoring rule violations. If a process reset takes place, the number of parts after that, it'll turn off the monitoring until the X number of parts are actually flow through the dimension item. The next section talks about leaders. Leaders is really more for the detail view. You can change the look and feel of a leader. A leader is what points to something on a picture. You can hide it. You can change the end cap. You can change the thickness, change the color. Basically, it's the aesthetics of the leader. The nominal tolerance limits tab determines where the data is located in the table. Notice variables are used in the cell references, and the variables are used in this different items in this sheet on this tab. So the column containing the data is the variable 1y, which is column D. The nominal cell is 1y row 2. The plus tolerance cell is 1y row 3, etc. Target shift. Target shift is a distance from the nominal that you actually want to target for the correction amount. Sometimes you may not want to target your process to the nominal target. You may want to shift it closer to a limit to extend tool life. You can put in a value here and it'll adjust your target. Last run reaction tab. This determines the rule violations and the instructions you want the operator to see for the last run statistics. You can set the number of parts to calculate last run statistics. Let's say I want to change that to 3. I'll change that to 3. The last run correction multiplier. This will take the calculation of the correction and multiply it by this value. So for example, the correction is minus 0.0061, and you see that in the instruction here. Maybe I want to flip the sign of that and cut it in half. Now, sometimes you need to do that for the process. This is tailored to the process. So if I put in minus 0.5, that'll cut that in half and flip the sign of the correction amount, which will change how the instruction is displayed up here. Standard deviation rule. If I can put in a standard deviation value, and if the standard deviation is beyond that amount, it'll trigger this rule violation and show the operator the instructions that are in here. Range rule. It's the same kind of thing. If I put in a range value, if the range is beyond that amount, it'll trigger a rule violation and then display that amount. If I leave this value and this value set to 0, it'll ignore those rule violations. Percent of tolerance rule violation. Here you can set the percent of tolerance criteria for the dimension item. It's set to 80%. You notice you've got a upper tolerance and a lower tolerance value you can put in. Again, it's to try to give you more flexibility and more tools for controlling your process. I may want to control it a little, maybe make the percent of tolerance higher on one side or the other. I don't know. Now, if this rule is violated, you'll see the instruction here, and you'll notice you have another variable reference, the last run correction. The last run correction will replace this variable. You have a whole list of values or variables that you can use to insert into this message. You need to be very specific on your instruction. It may be something like adjust tool comp by the deviation amount, something like that. The out of tolerance rule violation is the same kind of thing. If, again, you have a variable in here, and when the rule is violated, it'll trigger this message. As a matter of fact, that's the rule that was triggered here was an out of tolerance rule violation. Here it just says out of tolerance rule violation, adjust by minus 0.0061. Maybe I want to say something like adjust tool 1 by, and the adjustment amount, something like that. You need to be very specific. I'd probably want that same message in my percent of tolerance rule violation as well. The process reaction is looking at the process statistics, so the process info. The maximum number of parts to calculate process statistics is set to 40. If you can change this to anything you want. If there's more than 40 parts that flow into this dimension item, the parts will start dropping off. So the 41st part will drop off the dimension item. It's a first in, first out kind of a thing. The minimum number of parts before monitoring standard deviation spread. This is set to 30. If you're looking at the process reaction, you're really looking at like CP and CPK. And you really don't want to start looking at the standard deviation spread until you at least have 25 or 30 parts that you've measured. This will control that. So if I don't have 30 parts, it won't try to calculate the standard deviation spread. The number of standard deviations on each side of average used to calculate standard deviation spread. Right now it's set to 0. If it's set to 0, it'll turn it off. If you set it to 3, it'll be 6 sigma. 3 on one side of the curve and 3 on the other side of the curve. Process correction multiplier, that's along the same lines as the last run reaction. The last run correction multiplier. I can put in a value here. If my CPK is bad, you could potentially adjust your way out of it. Standard deviation spread rule, this is really the CP rule. If the CP ratio is violated, it'll trigger this rule violation. If your CPK rule is violated, it'll display this rule violation, this instruction. I'm going to leave that set to 0 for now. I'm going to save the changes to this dimension item and watch what happens. Notice our instruction has changed because we've got the out of tolerance rule violation. Also notice that the correction amount was divided in half and the sign was flipped. Those are the type of settings that you change in the dimension item. If you recall, our last run info, the maximum number of parts setting is set to 3. We only have 2 parts in this dimension item, so our last run info statistics and our process info are going to be the same. As we measure more parts, you'll see the numbers change based upon the number of parts in the dimension item. Let's return to the view mode and measure some more parts. So I'm going to click on the view button. I'm going to save my changes. I'm going to open up that simulator and measure some more parts. Notice, before I measure the parts, notice the dimension items that have a normal severity level are not displayed. That's because the setting that I changed in the header of the document. Let's go ahead and measure some more parts and let's watch what happens. Now you see we have 3 parts. Our last run info has changed because now we have 3 parts, and our process info is also set to 3. Let's measure another part. See the white dot there? We now have 4 parts for the process info, and now you can see that the 3 parts, the three blue dots represent the last run info. So you can see how that works. Now let's say I'm an operator, I'm going to make an adjustment. So I'm going to hit this button to acknowledge I'm going to make an adjustment on this dimension item. See the blue line. The blue line tells you that the part counter has been reset. Right at that point is where the statistics is calculated from now on. Notice up here at the top we have an output events button that appeared. When I clicked on that button, it captured that output event. If I click on that output event, it brings up this window where you can see a log, and I can expand that log to see the details. It tells you the information associated with the dimension item that I pressed, that button I pressed. I'm going to measure another part, and you'll see how that line will move with the data. So now I've got more parts in the system. Notice our process info, we have 1 part, and our parts info is set to 1 part because we put a process reset here. So if you have multiple process resets, you will see blue lines in your graph. Let's go back to the edit mode and talk a little bit more about editing reaction plans. I'm going to click on this dimension item, and we're going to talk a little bit more about the advanced tabs. I didn't really talk about the advanced tabs. You're probably wondering, okay, if I make editing changes to this dimension item, what about the rest of the reaction plans? Do the other reaction plans get updated? The answer to that question is yes. If I make any change to a dimension item or a reaction plan, if I click on the header and make editing changes to the reaction plan, it will affect all of the reaction plans in this list. The exception to that is advanced. If you see the word advanced in a setting, that only applies to the reaction plan you're working on. So for example, if I want to change the message overrides, basically you can override the messages for the last run info and the process info. Clicking on the advanced message overrides tab will allow me to make changes to this one particular reaction plan. The same is for the advanced output. Advanced output is used for writing data files. With Reaction Plan Manager, you can actually open up an output file and write adjustment information into the file. Let's switch to the template plan. Click on that dimension item. Notice we don't have the advanced tabs. That's because you're working with the template reaction plan. The template is really, as I mentioned earlier, the template is used to build other plans, so it really doesn't affect this. The same applies with the offline reaction plan. You're probably thinking, if I have to use the point, click, and configure method to edit all the dimension items in a solution, it can take quite a bit of time. That's a true statement. Let me introduce you to another tool called the Quick Dimension Edit tool. If you click on this button here, it'll bring up a screen, and it'll list all the dimension items in your solution. I can highlight all of them at the same time and make editing changes to those dimension items. So for example, if I know that all the dimension items, I want to use 3 parts in my last run statistics, I can click on the last run statistics, click on change that value to 3, click on apply changes to selection, and it'll update all the dimension items based upon the changes that you make. Now you have to be careful with this. Clearly you don't want to go in and change the nominal and tolerance cell locations because you're impacting all the dimension items in the solution. Let's go to the General tab. I want to get rid of the process reset buttons. You notice how it turns blue? When you see an item that's blue, that means you made a change to it. I'm going to go ahead and apply those changes. What I also like to do is I'll go and change the GD&T symbol for each one of these. I'll add the true position symbol, the diameter symbols, I can do other things as well. Maybe I want to change the number of parts, the total number of parts for the process reaction. Maybe I want to change that to 35. Say OK. And now I've made changes to multiple dimension items at the same time.